Every engine has a hidden speed limit, and it's not horsepower. Rev an engine hard enough and the little springs that snap its valve shut can't keep up. The valves start bouncing, the power falls off a cliff, and if you push it, a piston smashes an open valve and it's over. For decades, that wall stopped everybody. Then one stubborn Italian built the fix the rest of the industry called too fussy to sell. It worked. It won for 70 years. And now the company that made it famous is quietly dropping it from most of its bikes. That wall has a name. It's called valve float, and it has humbled some of the smartest engine builders who ever lived. Picture the top of an engine. Every four-stroke engine breathes through little trapdoors called valves. A spinning shaft with egg-shaped lobes on it, the camshaft, shoves each valve open, and a coil spring is supposed to snap it shut again before the piston comes back up. At low revs, no problem. But here's the thing about revs. Even at a fairly ordinary engine speed, those valves are opening and slamming shut around 40 times a second. Wind it up higher, and the spring has to fling that valve closed faster and faster, and at some point it just can't. The valve floats. It hangs in the air a fraction too long, or it bounces off the seat like a basketball, and your beautiful screaming engine suddenly makes less power the harder you try. You can actually hear it happen. The engine climbs toward the red line on the tachometer, and then just goes flat, like it's smacked into an invisible ceiling. Now, there is no single magic number where this kicks in. It depends entirely on the design. How heavy the valve is, how stiff the spring is, how aggressive the cam is. A well-sorted, modern engine can scream past 14 or 15,000 revolutions per minute on ordinary springs without any drama at all. But push an engine past what its springs were built to handle, and float shows up and quietly steals your power. You might be thinking, easy, just use stiffer springs. And engineers did exactly that, along with lighter valves and better steel. Stiffer springs really do raise the limit, but they cost you elsewhere. They drag harder on the camshaft, they make more heat, and they wear parts out faster. So it's a balancing act. And back in the 1950s, that balance was a whole lot harder to get right. Now, in the 1950s, the springs themselves were the weak link. The spring wire of the era just was not as strong or as consistent as what we have today, so at sustained high revs it would fatigue and snap. Springs broke so often that some racing bikes carried spare valve springs mounted right on the outside of the engine, so a rider could swap a broken one at the side of the track. So if you were an engineer back then, chasing more revs and more power, you kept running head first into the same stupid little coil of wire. So what if you just got rid of the spring? That's the whole idea behind desmodromic valves. The word comes from two Greek words, desmos, meaning bound or controlled, and dromos, meaning course or track. Put them together and it basically means the valve is leashed to the camshaft. Instead of a cam pushing the valve open and a spring guessing its way closed, a Desmo engine uses cams to do both jobs. One rocker pushes the valve open. A second rocker physically grabs the valve and pulls it back shut. There's no spring hoping to catch up, no float, no bounce. The valve does exactly what the camshaft tells it to do, all the way up, all the way down. That takes the spring's guesswork out of closing the valve, and it hugely reduces the float and bounce that limited those early engines. It isn't magic, every mechanical part still has a limit somewhere, but Desmo pushes that limit way, way out. If you ever pull the valve cover off a Ducati engine, that's what you're staring at. A tight little cluster of rockers and cam lobes, where a normal engine just has a spring sitting on top of each valve. It looks more complicated because it genuinely is. Here's an easy way to picture the difference. A spring valve is like a ball on a bungee cord. The cord yanks it back hard, and most of the time that works great, but spin it fast enough and even a strong bungee starts to lag behind. A Desmo valve is like a ball on a rigid rod. It goes exactly where you push it and exactly where you pull it. No lag, no slack. The faster you spin, the more that difference matters. Sounds obvious, right? Just close the valve on purpose. Here's the part that makes this a story instead of a footnote. Ducati did not invent this idea, not even close. The desmodromic concept is ancient in engine terms. There's a patent for a positive closing valve system from Gottlieb Daimler all the way back in 1889. There were Desmo experiments in a British racing speedboat around 1910, making a huge amount of power for its day. There were Desmo Grand Prix cars before the First World War. There were oddball Italian engines in the 1930s that used a whole separate camshaft just to close the valves. Bright inventors kept circling back to the same idea for decades, because on paper, it's clearly the better way to control a valve. And most famously, Mercedes-Benz put desmodromic valves in the W196 Grand Prix car and the 300 SLR Racer in 1954 and 1955. In the hands of drivers like Juan Manuel Fangio, those polished silver Mercedes race cars sweeping around old European road circuits absolutely dominated. So the idea was proven, it clearly worked. The problem was never whether Desmo could work. The problem was whether anyone could actually sell it. And that's the myth I want to clear up right away, because you'll hear people say engineers thought Desmo was impossible. That's not quite true. Everyone knew it was possible. What they thought was that it was impractical. All those extra cams and rockers meant more parts, tighter tolerances, higher cost, and a nightmare to keep adjusted. For a race team with unlimited money and mechanics rebuilding the engine every weekend, fine. For a factory trying to build thousands of affordable motorcycles that a normal person could own without a full-time mechanic, forget it. One by one, everybody who tried it walked away. Mercedes itself dropped out of racing after 1955 and took Desmo with it, which is exactly where our stubborn Italian walks in. His name was Fabio Taglioni, and he showed up at Ducati as technical director on the 1st of May, 1954. He was a mechanical engineer from near Bologna, brilliant, temperamental, a chain smoker, and famously certain about his own opinions. People who worked with him said that once he'd decided something, arguing with him was a waste of breath. Within about 40 days of arriving, he designed a little racing engine, nicknamed the Mariana, that went out and cleaned up Italy's long-distance road races like the MotoGiro d'Italia. If you know Ducati, three things basically define the brand's engineering, and Taglioni is the man behind all three of them. The Desmo valves, the 90-degree L-twin engine layout, the distinctive steel trellis frame. He pretty much drew Ducati's DNA from scratch. But the thing he really wanted to build from day one was the thing everyone else had given up on. He'd actually proposed a Desmo system at a previous company and been told no. At Ducati, the boss believed in winning races on Sunday to sell bikes on Monday, and he gave Taglioni the freedom to chase his obsession. They didn't call him Dr. Desmo for nothing. And here's the beautiful part. Taglioni didn't just copy the Mercedes design. He couldn't legally, and he didn't want to. He worked out his own system, that two-rocker setup I described, one rocker opening each valve and a separate one closing it, and he engineered around the existing patents. So when you hear that Mercedes sold Ducati the Desmo patent, that's a myth too. Taglioni did it his own way. His first Desmo engine was a tiny 125 cubic centimeters single-cylinder racer, and it had 3 camshafts instead of the usual one, which earned it the nickname Trialbero, Italian for 3-shaft. On paper, the numbers don't sound like much today. The regular spring version made around 16 horsepower. The Desmo version made around 19. But the magic wasn't just the extra power, it was that the Desmo engine could rev harder and safer than anything around it, spinning up toward 15,000 revolutions per minute on the overrun without floating a valve or throwing a spring. Nobody's little 125 could touch it. Now, Taglioni knew he had something special, and he did something wonderfully sneaky with it. Instead of unveiling it at a big Italian race where every rival and journalist would be watching, he and 2 mechanics quietly loaded a van and drove all the way up to a Grand Prix in Sweden at a track called Hedemora in July of 1956. Low profile, no fanfare. And the rider, a young Italian named Gianni Degli Antoni, went out and didn't just win, he lapped the entire field. Every other rider in the race got passed by a full lap. As the story goes, after an early test, Degli Antoni told Taglioni he'd never felt an engine like it, that not even a 250, a bike twice the size, could beat it. Picture the scene. A tiny red Italian single, barely known outside its own country, howling past bigger and more famous racing motorcycles on a fast Swedish road circuit, and putting a full lap on every one of them. It should have been the start of total domination. But this story has a gut punch in it. Just a few weeks later, Degli Antoni was killed during a private practice session at Monza. He was 27. The engine that was going to change everything had just lost the man who proved it could. Ducati regrouped, and the Desmo kept winning on the track. In 1958 at Monza, 5 of the little Ducati Desmos took the top 5 places, a clean sweep that told everyone the Sweden result was no fluke. And in 1959, a very young Mike Halewood, who would go on to become one of the greatest riders who ever lived, one-on-one at the Ulster Grand Prix. Then, at the end of the 1950s, Ducati actually pulled out of Grand Prix racing to focus on building bikes it could sell. The Desmo could have faded away right there as a cool racing footnote. But here's the strategic move that mattered most for the rest of us. Taglioni started figuring out how to take this exotic, race-only technology and put it into motorcycles you could actually buy. That took until 1968, when Ducati released its first production Desmodromic road bikes, a 250 and a 350 single, marked with a little D on the side for Desmo. Funny detail, those first street Desmos actually still had tiny, lightweight springs in them too, just to help seat the valves when you started the bike cold. But the real work, the high revolutions per minute control, was all done by the cams. The thing everyone said was too complicated to sell was now sitting in a showroom with a price tag. And then came the moment that turned Ducati from a maker of nice little singles into a legend. The year is 1972, and there's a brand new race, the Imola 200 in Italy, basically Europe's answer to the big American Daytona race. Ducati showed up with a new weapon, a 750 cubic centimeter engine built in Taglioni's other signature layout, a 90-degree V-twin he called the L-twin, breathing through Desmo valves. They hired a British rider named Paul Smart, who, and I love this, showed up with almost no time on the bike at all. He later said the thing was so long he thought it would never get around a corner, that it felt like it had a hinge in the middle. Then he went out and lapped faster than the reigning world champion on a factory MV Agusta. His teammate, Bruno Spaggiari, actually led for much of the race and looked set to win it, right up until he ran low on fuel near the end and Smart swept past. A Ducati 1-2 on Smart's birthday in front of a massive Italian home crowd of around 80,000 people. Picture 2 deep red Ducatis running nose to tail at the front of a home race in Italy, packed grandstands roaring, and out front a rider who'd barely even sat on the thing until that weekend. That win did something you can't buy. It gave Ducati a soul. Up to that point, Ducati was known mostly for small, clever, affordable bikes. After Imola, it became a maker of fast, desirable, exotic machines. And it built a whole line of road-going supersport bikes directly off the back of that race win, so ordinary buyers could own a piece of it. That is the exact moment Ducati turned into the thing we know today, the slightly mad Italian bike for people who care more about how a machine feels than whether it's sensible. And the beating heart of that reputation, then and now, was the Desmo engine. If Imola gave Ducati its identity, the Isle of Man gave it a miracle. In 1978, Halewood, who we met earlier as a kid, winning on those little Desmo singles, came back to racing after 11 years away. He was 38, basically ancient for a racer, and he'd been retired for over a decade. He climbed onto a Ducati 900 Desmo at the Isle of Man, one of the most dangerous races on Earth, and on his very first lap, he was already faster than his own old lap record. He beat the favorite and won. People who follow racing still call it the greatest comeback the sport has ever seen. Ducati sold a special replica of that bike, the Halewood replica, by the thousands, and there's a real argument that the money it brought in helped keep the company alive. By now you can see the pattern. Every time Desmo hit a track, it made history, and in the 1990s it found the stage it was born for. World Superbike racing became the Ducati Desmo show. It started with a bike called the 851, and its bigger brother, the 888, which introduced a 4-valve per cylinder Desmo design and started racking up championships almost immediately. Then came the one everybody remembers. The 916, designed by Massimo Tamburini, is still on a lot of lists as the most beautiful motorcycle ever made. Low and red, with those twin round headlights up front and a single-sided swing arm showing off the rear wheel, it looked like nothing else on the grid. And underneath that gorgeous bodywork was a Desmo V-twin that just kept winning. A rider named Carl Fogarty became a legend on them. Over the decades, Ducati has become the most successful manufacturer in World Superbike history, with more than 20 manufacturers' titles and well over 400 race wins, far ahead of anyone else in the class. The technology the whole industry had written off as too impractical had turned Ducati into the winningest name in production bike racing. If this is the kind of engineering rabbit hole you enjoy, subscribe, because this channel goes deep on the machines and the obsessives who built them. Now let's talk about the biggest stage of all. MotoGP is the Formula One of motorcycles, the absolute top. And Ducati's MotoGP bike has a name that tells you everything about the company's identity. It's called the Desmo Sedici. Desmo for the valves. Sedici, Italian for 16, because it's a V4 with 16 valves. They put their engineering religion right there in the name. In 2007, an Australian rider named Casey Stoner took that bike and won Ducati its first Premier Class World Championship, beating the mighty Japanese factories at their own game. That bike was developed by an engineer named Filippo Preziosi, and beating Honda and Yamaha with a Desmo V4 was a genuine shock to the establishment. Then Ducati went through a long dry spell where they built fast bikes that couldn't quite close the deal. And then, in the last few years, the dam broke. Lately, it's been a massacre. Ducati has become the team to beat in MotoGP, winning championship after championship. Francesco Bagnaia took the rider's title in 2022 and 2023. Jorge Martin won it on a Ducati in 2024. And in 2025, Marc Marquez won it on a Ducati as well, sealing yet another crown for the Desmo faithful, part of a staggering run of 6 straight constructors' titles that made Ducati look almost untouchable. The little idea from a van in Sweden now sits at the very top of the sport. So how far did the technology come? Remember that first 125 was a monster because it could rev toward 15,000. The most extreme version of Ducati's modern V4, the Panigale Five 4R, spins its Desmo engine to 16,500 revolutions per minute in top gear and makes well over 200 horsepower. That's a road-legal engine screaming past 16,000 into a range most engines will never see in their lives, with the valves still under total control. From around 19 horsepower in 1956 to north of 200 today, all built on the same core idea from that little 125. Instead of trusting a spring to close the valve, the cams force it shut mechanically. Which brings us finally to the twist. Because after 70 years of this, something surprising is happening. Here's the catch nobody puts on the posters. Desmo has a cost, and I don't just mean the price of the bike. All those extra cams and rockers have to be checked and adjusted, and because every valve is controlled on both the opening and the closing side, there's roughly twice as much to measure as a normal engine. That's the famous, or infamous, Desmo service. It's the kind of job where a technician sits hunched over the open top of the engine with a fistful of tiny metal shims, measuring gaps so small you'd want a magnifying glass. Historically, it was expensive and time-consuming, the kind of major valve service that could run you anywhere from several hundred to a couple of $1,000s depending on the bike and the shop. That's the kind of bill that makes people wince, and it's a big reason Desmo stayed a niche, enthusiast thing, while the rest of the industry stuck with simple, cheap, reliable spring valves that could go tens of thousands of miles without anyone touching them. To their credit, Ducati has stretched those intervals way out over the years, and modern Desmo bikes go far longer between services than the old ones did. But it's still more fuss than a normal engine, and that fuss adds up. For a long time, Ducati just accepted that trade. Desmo was who they were, but engines have to meet modern demands now: tighter emissions rules, longer service intervals, riders who want to just ride and not schedule a valve check. And so, quietly, Ducati started doing something that would have been unthinkable a generation ago. They started building engines without Desmo. Their big touring V4, the Gran Turismo, which powers the Multistrada adventure bike, uses ordinary spring valves, and it can go tens of thousands of miles between valve checks, a number that would have been science fiction on an old Desmo. For a bike meant to cross continents, that's exactly what a rider wants. Get on, ride, don't think about the top of the engine. And then, in late 2024, Ducati revealed a brand new mid-size V-twin, an 890 cubic centimeter engine, and it too dropped desmodromic valves in favor of conventional springs. This new twin is lighter than any twin Ducati has ever built. It makes strong power, and it stretches its valve service way out. For the everyday Ducatis, the ones most people actually buy, the 70-year-old obsession is being quietly set aside. Springs won, on those bikes at least. Now, before every Ducati fan in the comments loses their mind, let me be clear, because this is where a lot of coverage gets it wrong. Desmo is not dead, it's just being pulled back to fewer bikes. The flagship Panigale V4 Superbike still uses the Desmo 16 Stradale engine. The MotoGP bike is still pure Desmo. And here's the plot twist inside the plot twist. In 2025, Ducati launched its first proper motocross bike in about 50 years, a dirt bike called the Desmo 450 MX. And yes, the name is a giveaway. It's the first machine ever built specifically for modern motocross with desmodromic valves. Its single-cylinder engine makes over 60 horsepower, and it revs to nearly 12,000 revolutions per minute, which is genuinely wild for a motocross machine. Think about that for a second. Motocross is one of the most brutal environments an engine can live in. Constant abuse, huge revs, dirt everywhere, and Ducati looked at it and thought, this is a great place to prove Desmo still matters. Ducati basically used that bike to plant a flag. We are the only company on earth that puts the same valve system on our production bikes that we use on our racing prototypes. Nobody else can say that because nobody else stuck with it. Why keep it up top at all if springs have gotten so good? Ducati's own boss has basically said it's the system they know best, that they've spent decades mastering it, and that walking away from it entirely in racing would mean throwing out an enormous amount of hard-won knowledge and starting from scratch. When you've been perfecting one idea for 70 years, that head start is worth a lot. And there's the part you can't put on a spec sheet. A big chunk of Ducati's magic is the way its engines sound and feel. That deep, lumpy, slightly angry bark actually comes from the shape of the engine, the 90-degree V-twin and V4 layouts, and their uneven firing order, not from the Desmo gear itself. A spring valve Ducati still sounds unmistakably like a Ducati. But Desmo is woven right through the legend, the mechanical jewel at the heart of the brand, the thing that made all those wins possible in the first place. That whole slightly unhinged character is a huge part of why people fall for these bikes, and Desmo is stitched deep into the story. So read the strategy for what it actually is. Ducati is taking Desmo out of the touring and middleweight bikes, where lighter weight and longer service intervals matter more, and concentrating it where it always belonged, on the fastest, most extreme, most race-bred machines they build. Desmo is becoming the badge of the halo bikes, the crown jewels, rather than the standard on everything. Here's the part that gets me. For most of the industry, springs eventually got good enough that valve float stopped being scary, and Desmo's extra cost just wasn't worth it. But one company, because of one stubborn engineer, chased it anyway, all the way to the top of world racing, and turned a piece of engineering into a piece of identity. Taglioni died in 2001, but the thing he refused to give up on is still screaming around racetracks today, still winning championships, still stamped into the name of Ducati's fastest bikes. The real question now is what happens to the engines at the very top. If a future Panigale or a future MotoGP bike ever swaps Desmo for springs, that'll be the true end of the era. Until then, every time you hear a Ducati wind out to some ridiculous revolutions per minute without missing a beat, you're hearing the sound of an idea everyone else quit on, kept alive by the one company that never did.